All right, guys, welcome back for the second half of the 4.1 notes. We're just going to add a couple small details to what we talked about yesterday with antiderivatives and the general solution. So you'll notice you already have the notes, and where we left off yesterday, it starts up with day 2, particular solutions and antiderivative word problems. A particular solution is going to allow us to solve for that plus c. So it's going to look exactly like it did yesterday. We want to rewrite our f prime of x as dy dx equal to 4x. We're going to rewrite it in that differential form, 4x dx. And then in order to solve the problem, we integrate both sides. So just like yesterday, really what happens here is we're saying, well, what has an integral or a derivative equal to 1 dy? That would just be y. And on the right-hand side, I will have 4. And using the power rule, x squared over 2, and plus c. So as you see, nothing at all has changed since what we talked about yesterday. The difference is that they've provided you with what we call a particular solution. So now I know that when I plug in 0, I'm expecting to get a 6. So that would mean that 6 is equal to 2x squared plus c. And I could go ahead, and I could solve for my c value. Should have written it as 6 equals 2 times 0 plus c, and so c is 6. That means that I can rewrite my general solution with that specific c value in mind, and I've solved for the particular solution where the derivative would indeed be 4x. You can check your work quickly. And the function's value at 0 is 6. So I'm meeting both conditions. The second one that I've picked out here is a second derivative problem, and you'll notice that it has more conditions given. If you want to find the function given the second derivative, you just have 2 processes to go through. So if I integrate that second derivative, right, dx of sine of x dx, then when you integrate the second derivative, right, I would get the first derivative. I'm going backwards. And the integral of sine x would be negative cosine x. You're just using those memorized values. And so I have my plus c. So there's my antiderivative. I would want to go ahead and use the first condition. The f prime of 0 is equal to 1. So if f prime of 0, right, that would mean that I'm plugging in a 0. I get negative cosine of 0 plus c, and I know that that is equal to 1. So I'm using that condition. I can solve this. Cosine of 0 is 1, so this would state that negative 1 plus c is equal to positive 1, and if I add 1 to the other side, c is 2. So I can rewrite my first derivative then as, I'm going to go back to that initial antiderivative, negative cosine x plus 2. I want to go all the way back to my first derivative, so I'll integrate the first derivative. I want to go all the way back to the function, so I'll integrate my first derivative to get back to that function. The integral of f prime of x would be equal to f of x. And I would need to integrate the negative cosine x plus 2. Because I have 2 terms, there truly should be a set of parentheses here, and my dx at the end. So I can go ahead and I can solve that, right? The integral of cosine is sine, so the negative there is going to give me negative sine of x. The integral of 2 would be 2 times x, and plus c. I always like integrals because you could always check your work. The derivative of negative sine x is negative cosine x. The derivative of 2x is 2, right? So if you understand the relationship, you can kind of check your work as you go. I'll use that last condition, right? This is my f of x function now for the general solution. If I want to find the specific solution when x is 0, then that would mean that I'm plugging in 0 everywhere I see an x. And I already know, based on the information at the start of the question, that this should equal 6. So sine of 0 is 0, 2 times 0 is 0, and overall I get c is 6. So my solution overall, f of x, so it's way at the bottom, f of x is equal to negative sine x plus 2x. That was my antiderivative. And instead of writing plus c, I'll use plus 6. I'll pause here. We're going to switch gears and talk about position, velocity, and acceleration next.